Welcome back. Let's now solve another problem. I have a hook here, and this hook is subject to two forces, F1, which is 250 newtons, and F2, which is 150 newtons. And there's lines of action meet here. And now I'm gonna draw two axes. This one is U, and this one is V. However, they will not be perpendicular to each other like the usual X and Y axis. They are positioned differently with respect to each other. Your axes don't always have to be perpendicular to each other. Maybe for some reason you want to know what the forces are along the U and V axis. And so then you just define your axis like this. And so here, this angle, that's 105 degrees. Then this angle here, that's 30 degrees. And also this angle here, that's 30 degrees. And so in this exercise, you have to decompose your F1 and F2 vectors along the U and V axis. You have enough tools from this course to do it. Try it out on your own first, and then see the solutions in the next video. Thank you very much. Welcome back. Let's now solve this problem. Let's now decompose these two force vectors along the U and V axis. Let's start with F1. In order to decompose this force vector along these two axes, it's good to think of this F1 vector as a resultant vector. So what I will do, I will draw this axis here again, and so from the origin, I draw my F1 vector. If I think of it as a resultant vector, then the vectors along the U and V axis, these are the vectors that I should add up in order to get this resultant vector. So you are already familiar with the triangle rule. I can draw one vector along the U axis up until here, and then another vector parallel to the V axis like this. This vertical vector, it's just the shifted version of this one here. And if I choose to use the parallelogram rule, then I can also draw a vector here, which is the shifted version of this one. So if I want to decompose F1 along the U and V axis, then I have to find this vector that I call F1U and this vector that I call F1V. You already know that this is 105 degrees, this is 30 degrees, and so what I need to do now, I need to find some more angles in this triangle. For example, I would like to find this angle, phi, but since this lower triangle and this upper triangle, they are the same triangles, I know that in this upper triangle, this is 30 degrees, and this is phi. And so now it's very easy to find phi. Phi equals 180 degrees, which is this one here, minus 105 degrees, which is this one here, minus 30 degrees, which is this one here. And so phi equals 45 degrees. And now we can also find this angle here. Let's call it alpha. Since you know that the sum of all the angles inside a triangle is 180 degrees, and you know that this is 30 degrees and phi is 45 degrees, then alpha equals 180 minus 45 degrees minus 30 degrees, and well, that will give you 105 degrees. And so now you can write down the sine law. You can have F1 over sine alpha. F1 is this one here, and that would equal F1V, which is this one here, over sine 30 degrees. That's the opposite angle to F1V, and that would equal F1U, which is this one here, over sine phi. You know your F1, you know alpha, you know phi, so now it will be very easy to find F1V and F1U. F1V, it would equal 250 times sine 30 degrees over sine 105 degrees, and that's 129.4 newtons. So this one was 250 newtons, then alpha was 105 degrees, and then to calculate F1U, I will have 250 times sine 45 degrees over sine 105 degrees. And that will give me 183 newtons. Again, this phi, it was 45 degrees. And so there you go. We have decomposed F1 into U and V axis. This is the U axis and this is the V axis. And now let's do the same thing with F2. It equals 150 newtons. This is 30 degrees here. And again, we have to think about F2 in terms of a resultant vector. You need to add up two vectors in such a way that you will end up having F2. One vector is along the U-axis and another vector along the V-axis. So let's call this one F2U and this one F2V. We are adding them up using the triangle rule. And so again, I can draw a line here parallel to F2U and another line here parallel to F2V. So essentially I have two triangles here. If this is 30 degrees, then this is also 30 degrees because these two triangles are the same triangles. And if this is F2U, then also this one is F2U. And this is F2V, so this one is also F2V. And so I would like to find this angle here that I call theta, which is the same one like this one here, theta. You already know the phi angle here, and since this is 30 degrees and this is 30 degrees, then theta would be 180 degrees minus phi minus 2 times 30 degrees. So theta equals 75 degrees. And then I would like to find this angle here as well. Let's call it beta. And beta equals 180 degrees minus 30 degrees and minus 75 degrees. And that will also be 75 degrees. And again, you can use the sine rule. F2 over sine beta equals F2V over sine 30 degrees equals F2U over sine 75 degrees. This is 150 newtons. This is 75 degrees. So you have to find this one and this one. If you do that, then you will find that F2U equals 150 newtons without even looking at it. Why? Well, look, this one, it's F2 over sine beta, and beta is 75 degrees. And then this one here, in the denominator, you also have sine 75 degrees. So in both cases, you have sine 75 degrees in the denominator, and they are equal to each other. So if F2 is 150 newtons, then F2U must also be 150 newtons. So you see, when axes are not perpendicular to each other, then you can have a situation where your resultant vector is equal to one of the vector components, even if another vector component is not zero. So even though you have F2V, which is not zero, F2U still equals 150 newtons, which is equal to the resultant vector, which is also 150 newtons. The only thing is that if we assume that the positive U-axis is in this direction and positive V-axis is in this direction, so I'm going to put plus here and plus here, then F2U really equals minus 150 newtons. And now F2V equals 150 times sine 30 degrees over sine 75 degrees, and that will be 77.6 newtons. So that's this one here, F2V, 77.6 newtons. And this one is positive because it's in the positive V direction. And one more comment. Actually, if you think about it, then it makes sense that F2U equals F2. If you look at this triangle here, where this is F2, and this is F2U, and then here you have F2V, then you know that here you had 30 degrees, but then theta and beta, they were equal to each other. They were both 75 degrees. So you have 75 degrees here and here. So since you have two equal angles here, it makes sense that these two sides, they are equal to each other. Both of them are 150 newtons. And there you go, you have decomposed both vectors along the u and v axis. And now if you want to, you can add up the components along the u and v axis. Let's say the total force along the u axis is the following. F1u plus F2u, that's 183 newtons, minus 150 newtons, because you can see that these components are in the opposite directions, and that will give you plus 33 newtons. And then along the v-axis, you have F1v plus F2v, so you have 129.4 plus 77.6 equals 207 newtons. So the net force in the u direction, that's 33 newtons, and then in the v direction, it's 207 newtons. And so if you were to add up F1 and F2 vectors, then you can do it in two ways. Either you take your F1 vector, which is this one here, and then you add up your F2 vector, which is this one here. So F1 this one, F2 this one, and then you would get your resultant vector, or you will get the exact same answer if you add up these two net components along the u and v axis. So this component, which is 207 newtons, this one here, and then this component here, which is this one here, 33 newtons, which I can shift here, like this. So if I add up these two components, then you can see that I will get the same FR. Thank you very much.